Life was hard without machines, with little respite from mind-numbing chores, and dangerous. Most were serfs to a small privileged elite. When machines arrived, energy was captured, work transformed, and leisure time became everybody's luxury. Machines also helped change women's role in society and increase life expectancy. Well, isn't this what technology at its best should always be about? Unfortunately, there are still so many circumstances where they still can't help us. Now, can you imagine what it would be like to have a new kind of machine coming to our rescue in case of natural or man-made disasters? Doing work so degrading or so dangerous that nobody should do it? Boosting workers' productivity? Helping the ever-increasing number of elderlies live an independent life? Or simply taking on chores all of us would gladly do without? Indeed, in the past century, we imagined robots, mechanical replicas of ourselves, aptly named after a Czech word for heavy job. But even android robots are not meant to be human replicas. However, the world is full of other things we still call robots. They are some of the most useful machines we have. Inside factories, for example, they are precise, reliable, and indefatigable. Indeed, much of Europe's welfare depends on its leadership in robotics. Unfortunately, today's robots based on mechatronics have limitations and can't operate in complex real-world conditions yet. As we ask more of them, they soon run into what we call robotics bottleneck. They become too complex, inefficient, costly, difficult to control, and not safe enough to interact with people. That's why we want to create a new robotics, one grounded on very different scientific foundations. We will tap the biggest existing reservoir of effective engineering design principles, those that have been conserved in evolutionary history, and let animals and even plants or bacteria routinely solve problems that now elude even the most sophisticated robot, and much more reliably and efficiently. Our mission is to borrow 4 of their secrets. The first is simplexity, the variety of elaborate strategies brains use to rapidly deal with complex information and situations and simplify their tasks. Such strategies, explored through experimental and mathematical means, will help find the control principles that will lower the computational load on the new artificial brains. The second is morphological computation, or how the body takes on part of the control through the shape and the mechanical properties of its parts. In living organisms, there is a distribution of labor between the brain, the body, and the environment itself, which constantly interact and influence each other. We will exploit the shape and characteristics of a robot's parts to outsource computational tasks, thus simplifying construction and control. The third is sentience, the ability to integrate perception, cognition, and action, and interact with the environment. The insights gained from it will help robots act in the real world safely and productively by relating to people and other machines. The fourth is multifunctional micro and nanomaterials, which combine complex properties and functions with high energy efficiency. Evolution has optimized living beings to the point where they can perform complex tasks with minimum energy use while being highly versatile and robust. Tomorrow's robots will be based on a new family of hardware and will have less components, higher compliance and adaptability, and lower cost. As we begin to understand nature's design solutions, we reverse engineer them. The models we build help improve our understanding. This, in turn, helps build better and better models. We can also go beyond nature, for example, by providing connection to the internet or GPS. And we won't have to wait till the end for results. New insights and useful applications are likely to be obtained all along the way. We will unite scientists and engineers from information and communication technology, neuroscience, material science, tissue engineering, energy management, design, humanities and social sciences in a global scientific adventure led by Europe. And we will deliver 5 experimental and deployment platforms. The goal is to create a new science, to build a new generation of much smarter and much more useful machines that are affordable, sustainable and dependable, to help start new, disruptive, high-growth industries. Robot companions will make our lives safer, more independent, productive and creative. Just as technology at its best has always done.